Hello everyone. So ComfyUI recently updated their desktop version called ComfyUI version 1. It has been released for closed beta, and I guess they are sending emails right now. I have joined the waiting list, so we are going to check that out soon. What it does is provide desktop version software where you can just click the exe files or installer files and do a typical software installation to get started with ComfyUI on your local machine. It is cross-platform, supporting Windows, macOS, and Linux. So for Mac users, you don't have to keep asking in the comment section if ComfyUI works for you or not. But anyway, if it works for Linux OS systems, it should work for Mac. Right now, the package for ComfyUI itself is a lightweight package with a bundle size of 200 megabytes. That doesn't include checkpoint models and ControlNet models, all those few gigabytes or 10 GB files like Flux checkpoint models. So be aware of that. This number doesn't include those model files. Also, ComfyUI ships with default installed nodes directly from the ComfyUI registry with the latest versions of the custom nodes. This will be much easier for many people who just want to get started with ComfyUI. No more manually installing custom nodes, dragging them into folders, or using command prompts to do all that tech nerdy stuff. Right now, or once it releases to public beta, you will be able to run it just like normal software. Of course, the drag and drop custom nodes and node-based interface will remain the same, like these examples in this animated banner on top. Coming back to here, it automatically imports resources from your existing ComfyUI. This means once you import your input files, models, and output, it can reuse those directories that you already have in your existing ComfyUI system. I'm not sure if the Pinocchio installer will still be workable because that operates differently, but I don't think you need the Pinocchio installer anymore if you're using ComfyUI because what they have now is just an installer for ComfyUI, right? So why not just directly use something in a straightforward way? There's a brand new user interface on the top bar, menu bar, and other minor UI stuff, which is different from the traditional menu bar on the side. You'll see the menu bar on top just like word processors and software you're used to, like Excel, PowerPoint, whatever, on the top right here. And because it's local software, you won't have to do much manually like we do now. It's much more optimized for file-based operations on your local machine as integrated native software. That's the key of this ComfyUI update, and the good thing is it has a workflow browser. So when you have multiple workflows, like me, hundreds of workflows in your folder, you have a browse management place just like what you see here. Here are the template workflows. They have workflow management visible on the sidebar here. That will handle workflow management without using a file-based system, I guess. But of course, if nerdy geeks prefer to export file-based JSON files, you have the freedom to do that, because a lot of server-side ComfyUI also needs those workflow JSON files to run some automation workflows on the server side. So enough about that update. It's very self-explanatory. All these installations are just clicks without needing any tech knowledge. Next is the big news of Stable Diffusion 3.5. Now, Stable Diffusion is back in the game, hopefully. I have to quote that because when I see this big picture, all this transparent water looks so plastic. It feels like plastic stacked on top of this woman's head. But anyway, this is going to be following up with version 1. Stable Diffusion 3.5 is also supported in the existing latest ComfyUI that we're currently running on the public release. Stable Diffusion 3.5 has 3 models. It looks like they're following the path of Flux, where Flux has Pro, developer versions, and Schnell versions. Stable Diffusion 3.5 has large versions, large turbo, and upcoming medium versions coming soon at the end of October. It is an 8 billion parameters model for the 3.5 large model. They offer so-called superior image quality, and we'll see that soon, hopefully. The turbo, of course, brings faster, fewer sampling steps. They say it generates high-quality images in just 4 steps. I guess not many people or companies interested to train Air Stable Diffusion 3 series of models right now for low-step distilled model, so maybe that's why they trained the turbo by themselves. Usually, back in Stable Diffusion 1.5, there were lots of third-party companies based on that base model, training the LCM Turbo or Lightning Low Sampling Step model. So I guess that's what it is. We can try that in other videos for the large turbo. In this videos, I will only try the 3.5 large and see how good the quality is supposed to be and how it's going to be used. First, we have to download the checkpoint models. and put them into the models folder checkpoint subfolder. Same as before, we need to download the clip G, clip L, and the T5XXL clip encoder save tensor files. If you've run the Flux models already, you should have the clip L and T5XXL already. Some people might have the FP8, and here it's using the large FP16 by default. Clip G is something you might not have downloaded yet if you're using the Flux model. For me, I just downloaded this one and added new clip models to my system. Or low RAM solutions, ComfyUI.org has trained or compiled FP8 scale models for the 3.5 large models as well. Right here is the link for the SD3 large FP8 scaled models. The original large models file size is very similar. As you can see, 3.5 large save tensor files are 16 GB file size. It costs that much to download. Well, it's very familiar and similar to Flux in file size. We have the 3.5 large FP8 scaled versions compiled by ComfyUI.org, downsized to 14 GB file size. This only runs for FP8, so remember, if you're running the FP8 versions, you have to use the T5XXL FP8 clip models. And I guess you guys have already downloaded this when using Flux image diffusions, so the same rules apply. Go play around with that, use FP16 and FP8 for low VRAM and low RAM to consume less memory. They have two workflows here. You can download that. I've tried this with the first workflow, which is going to be, of course, the full-blown FP16. Here we go. We've got the workflow text to image. Now let's refresh this part first. We're going to see, first of all, as you can see here, the clip encoder configurations. You can do two types of loading the clip. One is getting the load clip using T5 FP16, and then loading the clip L and clip G individually in the other dual clip loader and selecting the type SD3. The second option for loading the clip text encoder is loading all three together in a triple clip loader custom node. I think this is more convenient for people to use. We don't have to separate two custom nodes to load the clip, etc. Remember to change to SD 3.5 large if you're running the FP8 versions. Once you download these FP8 versions, you have to use the FP8 clip test encoder to run those files. Just like these examples here, T5XXL FP8 save tensors, and we're using the large FP8 scaled save tensor files for the checkpoint models. For the load checkpoint models here, we don't need to use the clip output from this part. Instead of using the triple clip loader, we're using this clip data individually loading, very similar to Flux models, where we're going to use separate clips, the clip loader, and the checkpoint or JigUF. I believe later on we'll have the JigUF quantization for SD 3.5 if this model can make the open source community happy, and some people will make that as well. The next step we'll check is the positive prompt and the negative prompt. Looks like the negative prompt is empty, and we don't need to type anything in there as we're using the new type of diffusion model. Yeah, so as you can see on the models page of the SD 3.5 large, I just did a quick run for testing, and it looks okay. Okay, let's go back to here. As we're using the new type of diffusion model, it's called Diffusion Transformer, and the stable Diffusion 3.5 adds some fancy stuff at the front of this DIT model type, which is multi-model. I guess that will add some little differences to the Diffusion Transformer model's architecture. So we'll see how that goes. First of all, it'll be a lot more convenient for users when using the Diffusion Transformer, the DIT architecture. Most of the time, like with Flux and now SD 3.5, we don't need to type the negative prompt for the text clip encoder to inject that data in the prompt area. So we can just collapse these custom nodes just for, hanging around purposes. It doesn't really do anything necessary. It's just making the connections to keep the K-sampler happy. Okay, so the important part is the positive prompt, which is where we're going to bring all the image generation stuff. So what I'm going to do is I have some text prompts to test with. Let's try something else instead of the default text prompt from the ComfyUI website. We're going to test this one. And for the latent image, we're going to use empty SD3 latent image, just like what we had before. That doesn't change much for SD3. Although, of course, you can use the latent image, or I guess if you're using it for image to image, that would be something like load image and encode image for latent image. Yeah, that's going to be for the image to image structure as a way of loading an image. And you need the VAE from the SD3 large models that's already included in the checkpoint. So here, let's go back to the SD3 empty latent just for the text to image part. We'll try the image to image in the next step. So again, remember to check out the models, checkpoint models, and the clip loader. There will be some differences. For FP16, you've got to use the default SD3 large, which is here. And basically, that's the way of doing it. If you're using the FP8 clip loader, you're going to download the ComfyUI compiled FP8 scaled versions of SD3 large. So remember to choose the right one before you run any image generations here. Let's try this one. I'm not going to save this image, just preview it for research demo purposes. As this is the first time loading this image, it will take some time to load up those 3 clip text encoders and also the checkpoint models of stable Diffusion 3.5. It starts generating. It looks like my computer isn't going to be cracking or lagging a lot. Okay, so we've got the first image generated here with SD3. Well, let's check the speed first. The speed here is 22 seconds for the first time generation. And yes, for FP16, it does perform a little bit laggy in the VAE part. But after that, when the processing goes to the sampler, the K-sampler, it starts getting smooth. Overall, the performance doesn't cause too much lagging or try to freeze your computer like it's stone, not too much. There's a little bit when we start loading up the clip and the checkpoint models. Let's try the other prompts and see how that goes with the futuristic styles. Here, I've got another text prompt for futuristic female warriors dressed in all-white tactical suits. So let's check out this one. This time, I'm going to see if we change other dimensions for the latent image. Let's say we go here, just change a little bit on the width and see how that goes. Also, the CFG is able to be tuned up above 1 as we've tried in Flux, which usually by default is using 1, right? So here, as they mentioned, the CFG is able to run other than 1, which as you can see, I set it to 5.5, and let's try by default, like what we used to do, 7 or 6. That's also workable for images. For this image, it looks a little better, an improvement for SD 3.5 compared with the previous SD3 medium where the hands were going crazy and just didn't look like human character. But to be honest, by only seeing the image generation result, it is not good as Flux. Let's try another prompt again. We've got human characters central to this generation. Hopefully, there's some improvement for the characters in this 3.5 version. Meanwhile, as you can see in the command prompt window checking the generate process, it's loading well, pretty smooth. Although I'm using the FP16 text clip loader and using the SD 3.5 large without the turbo, it's still able to load pretty smoothly. While I'm recording these videos, it still hasn't got any lagging feeling compared to Flux that I first tried. And look at the image, the quality of the image looks okay, but still far away compared with Flux with the same prompt, although it looked different in Flux model, as you can see. For one sampling, it looks okay for the first try, and it doesn't do any fancy detailers, all kinds of multiple K-samplers, etc. This stuff is just a simple text-to-image workflow without any special custom nodes here. Other than human anatomy, other objects look okay. For example, the sword, or we call the Japanese katana. The handles are normal. Sometimes when I generate the katana in Flux, it looks oversized. Look at the handle here, it's too long. But this one, the ratio of the handle looks okay. It does have the handmade wrapping on the handle. So the third example here is dancing woman made of golden and colorful dust mixed with a fabric design, high-key dynamic lights, camera moving around dancing woman. And we finished the generation of this golden dust woman. Let's see how they perform. It looks like it has the old DCs from the previous SD3 versions. That's something I found out. And look at this one. Compared with what I generated with Flux, this is from Flux Turbo. Not even the Flux normal version models. This is from a Flux low-step Turbo. Although, of course, the face isn't going to be detailed using 8-step like that. But well, Stable Diffusion, why are you become like this? Let's give it another shot. This time I'll lower the CFG and see how that goes. Right, let's go back to 5, CFG 5. So, no more excuses for whatever reasons, etc. Go back to default settings from what they have in the ComfyUI download workflow examples here, and hopefully, actually it's running pretty smoothly for the generation for SD3. As you can see, the sampling bar is moving and using FP16. In the meanwhile, I am recording screen. The system haven't feel laggy and it looks pretty smooth for the sampling generations. And we got another image here. Well, it looks too futuristic or too fantasy style. And actually, this is doing what's coming from the text prompts, like a golden lion and colorful dust mixed with the fabric design. And then the dancing woman is made from this kind of material, and it looks alike. For the image, I still prefer Flux generated image for this text prompt. And this processing part is very smooth, even though this is large T5 text encoder FP16, and this is the result of the fantasy style image. This time it looks okay, but I want to see what if we have a full body view of the character, if that's going to be twisted, the legs and arms, or extra legs, extra arms, something like that. We are going to try another dimension and see. So far, the close-up shot like this one is pretty nice, I would say. It looks like those video games, like Japanese-style video games from this shot here. So this is another image generated using the new dimensions here and another portrait-like image. Well, this looks okay for the human-like character, but haven't seen the human anatomy ratio yet. So at this moment, we can't say good for the anatomy part. But so far for the face looks normal. I am still skeptical about this model, as we have bad experience on SD3 medium. Let's try another prompt and see what human anatomy and the ratio this AI model can generate. Throughout the testing, I've tried different CFG values from 5.0 to lower, eventually going to 3.5, then 2, and getting better at 2. But when I went down to 1.5 and finally to CFG 1 and tried 4 images at the same time, it did generate results. Let's check out something that looks a little weird from the generated result that I got in SD 3.5. I feel that SD 3.5 is so plastic compared with what I have previously in Flux. This is the image from Flux, futuristic fantasy style. At less in Flux, human anatomy ratio looks normal, and also the water, although Flux still have lots of artifact skin. But SD 3.5, it is way more obvious for artifacts, and well, both image styles are not realism styles, it's just going for the 3D hyper-realistic style. But then in SD 3.5, as you can see, the water dropping on the characters looks so plastic. I don't like the water styles of this model, especially when I first opened up that web page of the ComfyUI blog post. I saw that header image on the top where the water cover on the character looks so plastic. And then right now I generated few images myself and it's feel even more plastic. So I wonder if that is the specialty or what kind of dataset they trained using for SD 3.5. And as you can see, when I change other CFG in this image that you see, there are more artifacts. And look at this one, it looks so scary on the face. The eyes don't look so normal with blue energy. The ratios of the body and whole image structure don't look nice. And although in Flux it's not really a real human ratio as well, but at least Flux provide better when we look at the Flux image, so I'm not sure how or what they improved for SD 3.5 this time. So for the test, by testing the FP16 of SD 3.5, honestly it is still freaking bad. With funky face, like plastic surgery, bad human anatomy ratio, and I don't like plastic water texture. So that's the conclusion from what I've tested. So I'll see you guys in the next videos. Have a nice day. See ya!